Pivotal Query Optimizer for the Pivotal Greenplum Database. Hello, my name is Mike Goddard. I'm a field engineer in the enablement group at Pivotal. I'm going to walk you through this module addressing the Pivotal Query Optimizer, starting out with why does it exist? Why was it built? Next, we'll segue into a demo where I'm going to attempt to illustrate the topics in this module, including the features and enhancements, cases when the PQO needs to fall back to the legacy query planner, and then I'll leave you with some references, a quick review, and then I'll urge you to go and try the labs on your own. We are in an era where the amount of data available to us is growing at a fast pace. Yet we need to derive insight from this data using patterns we've grown familiar with. SQL is key here. We know SQL. The BI tools that we've grown accustomed to generate SQL, and it's typically very complex SQL. We need to optimize these queries to run efficiently across vast collections of data. So this is why we have the Pivotal Query Optimizer. This figure appears on page 10 of the paper cited here, ORCA, a modular query optimizer architecture for big data. This was presented at the SIGMOD 14 conference in June 2014. They used the TPC DS benchmark, and this figure illustrates the number of queries which were optimized in green or actually runnable or executed in blue on each of the specified systems here. As discussed in the paper, this benchmark was an excellent benchmark for testing Query Optimizer, as it combines 25 tables, 429 columns, and 99 query templates for a total of 111 distinct queries. And you'll notice here Hawk, which used PQO, was able to run all 111 of those queries, followed by Cloudera Impala, which was able to actually run about 20 of them. And then Presto and Stinger came in somewhere down the line there. And that's in terms of functionality, that they were actually able to run these to completion. Just to clarify some of the terminology that will be used throughout this module, ORCA is the name that was originally used to refer to PQO. And there are also going to be references to Hawk, which is Pivotal's SQL on Hadoop capability, which you could think of as a Greenplum database with its data on HDFS. So now I'll jump into the demo. And this, to do the demo, I'm going to use the Sandbox VM, which is available on Pivotal Network. If you haven't already done so, I recommend you download this VM and start it up. The download size should be less than 2 gigabytes, and you can find one for VMware and one for VirtualBox. So you get it by clicking on the middle blue box on this URL, greenplum.org. So what we're going to do in the demo is go through querying a partition table without PQO and then with PQO. Just look at the differences. We're going to activate and deactivate PQO at the database and at the session level. We're going to show that it's possible with PQO to update the column used in the distribution by clause. And also you can do an update in the column used as your partition key. Okay, the first thing to do is to query a table. This table here, fact on time performance, that you can see here has many partitions. So the first thing we're going to do is just illustrate how to show the state of the optimizer. So it's on. If I wanted to alter the database demo, the one we're logged into, to turn the optimizer on for that database, I would use this alter database command. So in order to show the legacy planner first and how it behaves, we're going to turn the optimizer off. And then I'm going to do an explain on this select which involves a lot of partitions in this table. So let's just pop that out and see what that did. So as you can see, starting at about row 16 here, the plan enumerates many, many individual partitions. And this is with the legacy query optimizer. Okay. So now I'm going to do this. This is another way to alter the behavior of the planner versus the optimizer. So I'm going to just say reset optimizer. That'll turn it back to on. And now we're going to do the same thing we just did, only with the pivotal query optimizer activated. So what you'll notice here in this explain plan is it's far more compact. What we have here in line 21, it says partitions selected 37 out of a total of 46. The optimizer is on, and the status is that it's PQO, and it gives you the version 1.597. Okay, so that is a much more compact query plan. I am now going to run a select, just to do that actual select that we just got the explain plan for. And there we go. I just limited it to 10 rows. So we get the average delay in minutes by airline for that date range. And we ordered it by the most delayed airline. Okay, so let's close this. And let me open up the second thing I wanted to show. And this just illustrates that with the planner, you're not allowed to update the column that's in the distributed by clause. So in this case, we have a table. The table is called T. It has 3 columns, A, B, C, and it's distributed by A. And I've already run this, which is I've loaded the table with a few rows of data. And so the first thing is we'll show, we'll set the optimizer to off. That was my mistake. And run that, just turn that off. Just verify that it's off here by show optimizer. So it's off. So let's get an explain plan on this update query. So we get an error here in red. It says cannot parallelize an update statement that affects the distribution columns. Okay. That's what we expected. Now we're going to reset the optimizer. Again, verify that it's set to on. And let's get an explain plan for this query again. So in this case, it works. We can do it. Here's the split operator that basically splits this operation into a delete and an insert. And so therefore it's able to run something that affects multiple segments. So let's just kind of look at the precondition before that query happens. So we've got the values 19, 20, and 21 in column A. We'll run the update. And then we'll go ahead and do that select again now, 20, 21, 22. So we've successfully updated those values for those columns where A is greater than 17. Okay, the next part is, and this is different. The previous one was we were talking about the column that was used in the distributed by clause. In this case, we're going to look at being able to update the column, a value in the column that's used for partitioning the table. So this is different, but it's also a new feature of PQO. So we'll set the optimizer to off. And here we go. Now I am going to update the fact table, and I'm going to update the value of the flight date, and I'm going to increment it basically by 1 day for this particular value of origin airport ID, airline ID, flight num, and then flight date. So let's try to do that. Okay, so we get an error, and it says moving a tuple from partition, basically the part 2 partition to the part 3 is not supported. Okay, so again, we expected that, and let's go ahead and set the optimizer back to on. Oops. And let's go ahead and run this update again. Let's see what happens. Okay, so the update succeeded. So just another area where PQO behavior differs, and it operates in a much improved manner. This is the last example. In this case, there's a catalog query, and we're just querying GP segment configuration and PG file space entry tables and doing a join. So those are catalog tables. This is a short running query as well. So we'll set the optimizer to be on. Go ahead and verify that. It's on. And let's go ahead and select, do an explain on this select. So what do we get here? Okay. So here it says that even though the optimizer was set to be on, the status is that the legacy query optimizer is being used for this query. So this is one of these cases where you have a class of query that is not supported by PQO, so it just falls back automatically to the legacy planner. So here are some of PQO's new features. We have enhancements for a few specific types of queries. That would be queries against partition tables, and you'll notice in the demo you could see right away what that difference looked like. Queries that contain subqueries, and specifically correlated subqueries. Queries that contain a common table expression. That would be queries that have the with clause. In addition, PQO has some optimizations to improve join ordering, reordering join aggregates, optimizing sort orders, and also there are estimates of data skew in the statistics that are taken into account when the query is planned. So a bit more on features. With partition tables, we get dynamic partition elimination. With the planner, there could be instances where you would have an out-of-memory error for certain types of queries and involving partition tables. And as we saw in the demo, this is mitigated significantly with PQO. So correlated subqueries. Joins on columns with differing types on the left-hand side and the right-hand side of the join will no longer go to a nested loop join, which tends to be very inefficient. Queries with common table expressions, as I mentioned before. And then, again, the distribution of partition keys are now updatable, which is something that people have asked for. So in order to use the pivotal query optimizer, there are a couple of gucs that influence the behavior of the system. There's one guc called optimizer control, which you can set at the level of the system, the instance or the cluster, to enable or disable setting optimizer across the entire cluster. Then there's the optimizer guc itself, which can be set at 3 different levels. You can use gpconfig if you're the DBA and set optimizer to be on, as shown here. You can alter database DB name, set optimizer equals on or off. And then you've got a session or query level where within your session you can just set the optimizer. to the appropriate value. So all the legacy planner GUCs are ignored by PQO. So AnalyzeDB is a new capability. That it's a management script that ships with GPDB. So it's important to have statistics on the root partition of any partition table. So before you're going to use PQO in an instance of the database, you have to ensure that root level partition statistics are available. The legacy query optimizer didn't use these, so that's a change with PQO. So there's a GUC optimizer analyze root partition you would set to on, and then AnalyzeDB is highly recommended as a way to analyze the data and make sure that you have root partition statistics. So with PQO, there are some trade-offs in the performance that we get for big queries across big data. One of the trade-offs is that short-running queries tend to take longer, and because of the additional optimization overhead. With Analyze, as I mentioned before, it requires root partition statistics. DML operations have higher overhead, and that's due to the increased number of operations in these DML operations. For example, in order to support an update on a partition key or a distribution key, the update is a little bit more complex than it was with Planner. So if you're thinking about using PQO in an existing installation for an existing customer, don't set it as activated at the system or database level, because some of the queries that are already running on that system, you may see some changes in the behavior. So it's better to set it at a session level or a query level to improve the performance of the queries, when you specifically want that. So you also, caveats would be to ensure that the tables don't contain multi-column partition keys. And you also want to avoid using PQO with queries that involve catalog tables that are only on the master, PG attribute being one. So consider the enhancements that PQO brings for queries against large partition tables, queries that contain subqueries, correlated subqueries in particular, and queries that contain CTEs. For new installations that are not in production, set PQO at the system or database level as long as the following are true. The data model doesn't contain multi-column partition key, and no partition table has more than 20,000 partitions. If that's the case, you'd need to redesign the schema. Maybe go to a coarser grained partition specification. And always know that if PQO is unable to generate a plan, it will fall back automatically to the legacy optimizer. So some of the pain points in the planner that we saw this in the demo a bit. The query plans can get very large. This could lead to out-of-memory conditions. Updates on with joins on partition tables can generate very large query plans. Also, the partition selecting side of the join would be executed twice. In PQO, the plan size is not dependent on the number of partitions because they're not enumerated in the plan. And this leads to, so the plan that you see when you run and explain is basically a serialization of the query plan. So that's indicative of how large it is and how much memory that data structure would occupy. So with the smaller plans, you're not going to get the out-of-memory errors that you might with the planner. So if there is a way to eliminate partitions, PQO will find it. And importantly, the partition selecting side of the join will not be executed redundantly. So just to review, what is a subquery? A subquery is a query that's nested inside of an outer query. So a correlated subquery is a query that uses some values from the outer query. And in this example, the table part is referenced within the subquery there. You can see that p1.brand, so the brand column from the outer table is referenced within the inner query. So that would be a correlated subquery. So why are they important? We find that they're really used a lot in certain workloads. BI and reporting tools tend to generate a lot of those. And that, if you look at some of the benchmarks, TPC-H and TPC-DS, you'll find that a fairly large fraction of those queries feature subqueries. If you create an inefficient query plan, you can end up having very long-running queries, possibly queries that just fail to terminate. So some of the optimizations that you can do are decorrelation and converting the subqueries to joins. So another class of query that's optimized with PQO is common table expressions. So this is a query with a with clause. And looking back at the graph that I showed earlier, 46 out of the 111 queries in TPC-DS contain CTEs. With the planner, CTEs would always be expanded, and that led to a potential for a deadlock during execution. With PQO, you don't have that behavior, so you have deadlock-free execution. So if we look at a CTE query plan, here's a query. If we look at sort of in the lower right, the orange, you've got this shared scan operator. So this new approach evaluates a complex expression only once, where multiple operators consume its output. And this allows Greenplum Database to deal with much more complex CTEs because it's not forced to fully expand them, but instead just deals with them dynamically. So some of the features not supported by PQO: the percentile window function, external parameters, sort merge joins, the cube operator and multiple grouping sets, utility and DDL commands that basically short-running queries that tend to hit the catalog tables. However, if PQO isn't able to come up with a plan for a given class of query, it'll just fall right back to the planner. The planner executes the plan and it gets executed. It's easy to determine if your query plan is generated by PQO. When in the explain plan, you'll see the PQO version is listed there. And then if the optimizer generated the plan, similarly, you'll see the optimizer status will be the legacy query optimizer. Whenever you have unsupported features that cause a fallback, you can look in the log, in PG log, and you'll see some notations. In this example, feature not supported by the pivotal query optimizer was roll up in cube. So you can do some forensics that way. It's pretty convenient. Finally, a few references. The top three are from the GPDB documentation site, and you can go, again, over the features, limitations, and how to enable PQO, and those are always very up to date. There's a great blog about the addition of the pivotal query optimizer, and this presentation was taken heavily from that. There is you can download the SIGMOD paper, and also in the GitHub repository for its GPORCA, you can actually get the source code for PQO. So to wrap up, big data, complex analytical queries, and BI tools pose immense challenges for query planner optimizers. PQO was built from the ground up to tackle this challenge. PQO can be enabled or disabled at the cluster or instance level using gpconfig if you're the DBA, at the DB level, or at the session or query level. And PQO requires statistics on the root partition for partition tables. And the analyze DB command is really good for this. At this point, I suggest reviewing PQO by jumping right into the lab. Thank you very much